In this video, I'm going to talk about how to solve right triangle through a couple of example questions. The goal is to use primary trigonometric ratio to calculate side length and angle measures in right triangles. Yeah, let's look at first questions. A farmer's cooperative want to buy and install a grain auger. The auger would be used to lift the grain from the ground to the top of a silo. The greatest angle of elevation that is possible for the auger is 35 degrees. The auger is 18 meters long. So what is maximum height that auger can reach? So the question is calculate maximum height that auger can reach. So this is 18 meters. This hypotenuse is 35 degrees. This angle in this right triangle. This is the right angle. So yeah, let's draw a diagram to model this problem. So this is hypotenuse. Okay, this is height. Okay, this is right angles. This 35 degrees. So this is opposite. It related to 35 degrees. And this is hypotenuse. Hypotenuse equals 18 meters. So this is adjacent relative to 35 degrees. So we named adjacent. And this is h. We want to find out. So because I know the length of hypotenuse, right? 18 meters. And we want to find out the height, right? The height, maximum, the height that auger can reach. So we use sin theta. Sin theta equals opposite over hypotenuse. Hypotenuse, right? So theta equals 35 degrees. Sin 35 degrees equals opposite. We don't know. Right? We set h. Hypotenuse is 18 meters, right? So both sides multiply by 18, so sin 35 times 18 equals h. So sin 35 degrees, so its calculator is 0.575 times 18 equals h. So h equals around 10 meters. So yeah, maximum height that auger can reach is above the 10 meters. Yeah, let's look at the second question. Determine the length of P in this right triangle. And 55 millimeter is the adjacent side to the 15 degree angles. So I named this is opposite side to the 15 degree angles and name this hypotenuse. So the question asks us to determine the length of P. Okay, so we know the adjacent, right? So it's we know cosine theta. Cosine theta equals adjacent over hypotenuse, right? So theta equals 15 degrees. Cosine 15 degrees equals, so adjacent is 55 millimeter. So it's hypotenuse we don't know. So we rearrange this equation. P equals 55 over cosine 15 degrees. 55. I look up the cosine 15 using calculator is 0.97 and it's roughly so equals 57. So the length of the P is about 57 millimeter long. Okay, let's look at the third question. Noah is flying kite and he has released 25 meters of string. His sister is standing 8 meters away directly below the kite. What is the angle of elevation of the string? So this question asks angles here, so elevation of strings. So this the hypotenuse is 25 meters. So this opposite side related to angle theta. So this adjacent side to the angle theta, we know it's 8 meters away, right? So we know 8 meters adjacent side, we know the hypotenuse 25 meters. So in order to determine the angle of elevation, this theta So we use a cosine of theta. Okay, so cosine theta we know is adjacent over hypotenuse. So it's cosine theta we don't know. So just write down cosine theta, but we know 8 meters is adjacent side and the hypotenuse 25, right? So we use the inverse of sine. So theta equals cosine inverse of cosine 8 over 25. Yeah, we look up this by calculator. It's around 71 degrees. It's 71 degrees. So this is 71 degrees. The angle of elevation of a string is about 71 degrees. Okay, let's look at the last question. Solve a triangle ABC given angle A equals 90 degrees, A equals 7.8 meters, C equals 5.2 meters. Solve ABC means to solve a triangle to find out the three lengths of the three sides, right? So it's and also we find out we have find out the angles, three angles. So we know C and 5.2 meters, A equals 7.2 meters. We have to find out AC, so it's easy, right? Use Pythagoras theorem. And find out theta, B, angle C. We can use a trigonometric strategy. So, okay. So we know, you look at angle B, we start from angle B, right? So this is adjacent to the angle B. This is hypotenuse. So we know the cosine theta, right? Cosine theta always equals adjacent over hypotenuse, right? So theta here is cosine B equals adjacent C or C hypotenuse A, so equals 5.2 divided by 7.8. So in order to find out the B, we use inverse of sine, right? Cosine. So B equals inverse of cosine 5.2 over 7.8. So equals, we already get it from the calculator, is 48 degrees around. So we know the B, right? Easy to find out C's. Right? So it's angle C equals 90 degrees minus 48 equals 42 degrees. So we know three angles. So next we determine the length, the AC, right? We let AC equals B. So according to Pythagorean theorem, so it's B squared plus C squared equals A squared. So B, we don't know, we copy it. C squared is 5.2 squared equals 7.8 squared. So B squared equals 7.8 squared minus 5.2 squares. So 7.8 squared equals 60.84 minus is 5.2 squared is square, right? So it's 27.04 equals 33.8. So with both sides take square root, so B equals positive negative and 30.8. So equals positive negative 5.8. So we take positive, B equals 4.8 because negative does not make sense, cannot be a negative for the length. So this is answer. B equals 4.8, 5.8 meters. This is 48 degrees. This is 42 degrees. So we solve ABC. We know three lengths. We know the three values angles. Yeah. Okay. So let's go to the summary. So a trigonometric ratio can be used to calculate unknown side lengths and unknown angle measures in a right triangle. The ratio you use depends on the information given and the quantitative you need to calculate. Second, to determine the length of the side in the right triangle using trigonometry, you need to know the length of another side and the measure of the one of the acute angles. To determine the measure of one of the acute angle in a right triangle, use trigonometry. You need to know the length of the two sides, right? So next is practice questions. So as practice make perfect. So this 1, 2, 3, 4, 4 questions here. The answer is listed under each questions. So another 3 question is here, and this answer is answer for this answer for this. That's it. Thank you for watching.